Good morning, guys. I am going to introduce the Prob and Stats unit today. Unfortunately, not having a very good day, so we'll see how this all goes. I'm sorry. The topic we're going to talk about today first is counting principles, permutations, and combinations, and then we're going to do some probability review. Just to start off, the counting principle is the basic principle that says if a decision can be made M ways and decision N can be made in N ways, then the two decisions can be made M times N ways. So what does that mean? Well, the ice cream shop offers a choice of 3 sizes of cones, 15 flavors, and 8 toppings. So how many different cones are possible if you choose only one size of cone, 1 flavor, and 1 topping? So there's 3 cone sizes, 15, and 8 choices to be made. So let's see, 3 times 8 times 15 is 360 different cones you could order. Virginia license plates consist of 3 letters. Okay, there's 26 letters in our alphabet. Now, it doesn't say they can't be repeated, so we're just going to do 26 times 26 times 26, followed by 4 digits. So then we have, now this confuses students sometimes. There are actually 10 digits in our number system. We have 0 through 9. That's a total of 10 different digits. So we have 10 times 10 times 10 times 10. Now, a lot of states, will say you can't repeat a letter or you can't use 0 if you're using it as an O or whatever, but this is just a generic question. So on our calculator, we could type this as 26 to the 3rd times 10 to the 4th. So 26 to the 3rd times 10 to the 4th, or just move the decimal over 4 places. We have a lovely, I'm going to write it over here, 17576 with 4 zeros. So 175 million different license plates we could make using those possibilities. All right, Nick's science test has a section with 12 true-false questions. So how many different ways can he answer these? So each of those 12 questions, he can answer 2 different ways. So we can do 2 to the 12th. Okay, true or false for 12 different questions would be 2 to the 12th, which is 4,096. I hope this is making sense. I usually just write out blanks, like for the license plate, you could have done, there's 3 of these, and then 4 of these. How many of each? So this was 26 times 26 times 26. All right, I'm not explaining things well this morning. I apologize. Factorial is this symbol, okay? And what factorial means is the product, in other words, you're multiplying, of all natural numbers. So if you write n factorial, it means the product of all natural numbers from n down to 1. For example, 9 factorial means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On your calculator, under the math button, if you arrow to the right to the probability menu, we're going to use those buttons for the rest of the period, or the rest of this section here. I thought I turned the math or the calculator on. I'm sorry. So we're going to math, which is right below these 2 over here, and we're going to arrow to the right 3 times to the probability menu, And we're going to actually talk about section 2, 3, numbers 2, 3, and 4 today, but the one we're talking about right now is number 4, the factorial. So if I go 9, math, right, number 4, I get 9 factorial, which is, sorry, it's cut off a little, 362880. Now, if you had something like this and you had to do it by hand, which would be miserable, it's not as bad as it sounds though, because when you did 17 times 16 times 15 times 14, okay, it's as bad as it sounds. 13 times 12 times 11 times 10 times 9, blah, 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 blah. But you're dividing by 11 times 10 times 9, blah, blah, blah. So all of those would divide out, and you'd only end up multiplying these. Definitely still don't want to do that by hand. Okay? So instead of, I can, here, on the calculator, I'm going to teach you a shortcut as well, though. If you wanted 17 factorial, you can do alpha window, and it brings up this shortcut menu, alpha window, and then number 9 is a factorial. And then if you said I'm going to divide by 11, alpha window, choice number 9. Okay. If you tried to do that in 2 steps, so 17, and I'm going to go the other way this time, math, arrow to the right, choice 4. It's huge. It's so big that your calculator won't put it out in as a real number. It puts it in scientific notation. That's still a real number, sorry. But some numbers, like if you did 60 factorial, I'm guessing that one's too big to do at all. Nope, I'm wrong. Okay, how about 250 factorial? Some of them, your calculator will just say exceeds the range of values, overflow. Okay, they're just too big, period. All right, so that's factorial. Sorry, I got a little carried away there. Somewhere I have that number that was an answer to that. 8910720. 891. Okay. This, by definition, 0 factorial is defined to be 1. I don't know that you need to know that for any reason, but it's not 0. It's by definition 1. Okay. Sorry. All right. We use factorials in the definition of permutation. It's n factorial over n minus r factorial. So this is when you arrange or line up objects in which order matters. And to calculate the number of ways that can happen, you use what's called a permutation, which uses factorials. All right, it says here, n is the total number of objects available, and r is the number, that should be an r, I don't know why I have a c there, that's going to confuse you terribly. Please don't put a c there. So we're going to do something with a c in a minute. The r tells you the number you're going to use. I'm going to say arranging, which I probably spelled wrong. All right. What you need to understand is that in this, where I say order matters, what that means, for example, I'm going to choose 5 of you to line up at the door. Whether you go first, second, third, fourth, or fifth is different. Versus if I was choosing 5 of you to hand a $100 bill, it wouldn't matter if I chose you first, second, third, fourth, or fifth. You'd get the $100 bill and you'd be happy. Okay? Does it count differently if I put ABC, ACB, this is if I was choosing three things to arrange. ABC, ACB, BAC, BCA, CAB, CBA. Those all count differently for arranging three things in order, okay? So when I'm putting three things in order and the count matters, I have three ways to pick the first one, two ways to pick the second one way to pick the last one, sorry. Okay, there's three of you standing here. I'm going to put you in line. So three, and then I have two choices, and then I have one choice for the last spot because I've placed the other two. So that's 6, not complicated, but that was when they all count differently. We're going to talk in a minute about when they don't count differently. If I'm just handing out a $100 bill, choosing, Abby, Bob, and Charlie, Abby, Charlie, Bob, Bob, Abby, Charlie, doesn't matter. The same three people. So all 6 of those would need to count as one group of students got the $100. Okay. So this permutation, I always associate permutation with probability, or I'm sorry, priority. Oh, so permutation I associate with priority, meaning the order matters, it's different. There's a priority given, okay? And we will talk about choosing a president and a vice president versus a committee where it doesn't matter what order you were put on the committee. So here's some examples of permutation problems. How many ways can you arrange the letters in this word? So all of these letters are different. So there are 1, 2, 3, 4, 5, 6, 7, 8 letters. So the first time I go to pick a letter, I'd have 8 choices, then 7 choices, then 6, then 5. So if I put 8, 2, 3, 4, 5, 6, 7, 8 blanks, I'd have 8 choices to pick from, then 7, then 6, then 5, then 4, then 3, then 2, then 1. So I could just do 8 factorial. If you want to use the permutation button that we're going to talk about here, it's out of 8, I'm putting in a priority arrangement all 8 of them. Okay? It's the same as 8 factorial because the definition is 8 factorial divided by 8 minus 8, or 0 factorial, which is 1. So we're just going to do these on the calculator. So you could either do 8 times 7 times 6 times 5 times 4 times 3 times 1, or you could do 8 alpha window here and use choice 9, 8 factorial, or the new one is the permutation button. So if you go to math, arrow over to probability, again, it is choice 2. P for permutation, where order matters or there is a priority given to something, okay? So you would pick choice 2, and then the new calculators allow you to just put these in these spots. So we'd have 8, arrow to the right over here and put an 8, and get the same thing. It's also on this shortcut menu, so we could go alpha window and choose choice 8. Whoa, choice, just kidding. Oh, I can't pick this. Alpha window. Oh, I have to. Alpha window, choice 7, and then 8. Oh my goodness. I might as well go home now. And 8. All right. We're going to go back 40,320 ways that we could arrange those letters. Now, this becomes a whole different question if we ask how many words can you make out of those letters, because not all of those arrangements would be words, clearly. All right, number 6 says 7 students are competing in a geography bee. How many ways can they finish first, second, and third? So this time you are not choosing all 7 students. There's only 3 places being awarded. But if there's 7 students to pick from, when you go back to pick a second place, there'll only be 6 choices. And then when you go back to pick third place, there'll only be 5 students to pick from. So in my mind, I would just type that in because that's faster. That's 210, I think. And I didn't have to do any weird buttons. But It is also out of 7, I'm prioritizing choosing 3. So you could also do that, and it should give you the same answer. All right, Melanie is taking 4 classes this semester. How many ways can these 4 classes be arranged on her schedule? All right, so here it matters because we're talking about arranging them in an order. So we're going to pick out of 4, she's prioritizing all 4. Or if we were picking, there's 4 ways she could pick her first period, 3 ways for second, 2 and 1, which is 24 ways, and there's no need to get fancy on our calculator. There are 16 players on a baseball team. How many ways can the coach pick a 9-player batting order? So order matters in batting order. So we're going to do 16 players, and he is putting in a total of 9. So this time it makes sense to go to the calculator. And I'm going to do, it is 16 times 15 times 14 times, all the way until you've filled up 9 blanks. But I'm going to go alpha window, choose number 7, and I'm going to put in 16 and 9. Or again, you could have gone to the math button. Okay, I'm going to put this over here so that I can write that number correctly. 41513472200. That's a lot of different batting orders. Okay, over 4 billion, I think. All right, there are 28 students in Mr. Miller's homeroom. How many ways can his students select a student council representative and an alternate? Now these are 2 different positions. Okay, one is going to all the meetings and one is just a backup, so they count differently. If Abby gets chosen for this and Bob for this, it's different than Bob for this and Abby for this. So that's why we're doing a permutation, not a combination. Now, you can do this. Out of 28, I'm choosing 2. My brain says it's easier to just, I have 28 to pick for the first choice, 27 to pick for the second choice. So 28 times 27, oops, I didn't type that right, is just 756 ways we could do that. All right, the next one, oh, this is permutations with, this is not on the quiz, but let me just talk you through this. If you're doing math team, this is important, but how many different ways can 10 letter arrangements are possible using the letters from the word automobile? So there's 10 ways that you're going to pick the letters, but down here you have to say how many of them repeat. So there's 2 O's. So we have a 2 factorial we're going to divide by because it's a repeating letter. And then what else? Does something else repeat? I guess not. So this would be the answer to this question, which is, I'm not very fast with my calculator on these guys. Okay, how many different letter arrangements? 9 letters, so using all 9, can be made using this word. Okay, there's 9 letters, but you have to say some of them repeat. So the P's repeat. And if you had 3 of something, you would put 3 factorial. But I think here the A's repeat, so you have another 2 factorial. So 2 times 1 times 2 times 1 is just 4. So we end up with 9 factorial divided by 4. I am hopeless. At doing these quickly. I got 90,720. All right, let me just check those. Yep, those are right. Again, not something you're going to have to know. All right, combinations are different. A group of objects in which the order chosen doesn't matter. And it's NCR, where N is the total and R is the number you're choosing. Now, the definition is that this time all of these different groups, all 6 of these, count as one group. It's the same committee. It's the same group of 3 people getting the $100, whatever. The order doesn't matter. So the definition, the formula is n factorial, divided by r factorial times n minus r factorial. And that's because it gives you a smaller, you have to divide by additional thing here so that it gets a smaller number of choices. Okay, this all counts as 1, not 6 different choices. So if Natalie has 16 close friends, how many ways can she choose 5 to be a bridesmaid in her wedding? So she's choosing out of 16, 5. But if they're all going to be bridesmaids and she's not prioritizing, her favorite friend to her least favorite, she's just picking them all, then it is a combination. And on your calculator, that is, under the math, over to the probability again, and it is choice 3. And out of 16, she was choosing 5. That's what I remember, but it's probably wrong. Was that the right numbers? Yes, okay. 4, 3, 6, 8. There is also a shortcut up under the alpha window button up here, and it is choice 8 this time. All right, so there are 24 students in Kyle's kindergarten classroom. How many ways can he choose 8 to attend his party? Okay, it doesn't matter what order they're picked in. The same 8 kids are going to come. We just want to count it, that same group once, not 8 different times. So we do 24C8, and again, you can do either the shortcut alpha window here and choose choice 8 and put in, I already forgot, was it 24 and he's inviting 8? So that's a lot of different ways still that he can choose these kids to come to his birthday. It would be even more, a lot more, if the order he chose them in mattered. 7, 3, 5, 4, 7, 1. Okay. I'm going to stop doing these and just set them up for you. It says Abby's adopting kittens from the pet store. There are 18 kittens, and how many ways could she choose? 2. So see, this time, if we were doing this the long way, we'd say, well, she could pick 18 ways or 17 ways. But then we'd have to divide by the fact that we have too many groups, because choosing the black one and the white one, or the white one and the black one, counts the same as 1. So we divide it in half. But on your calculator, it's just 18C2. So that answer, I said I wasn't going to do anymore, but that one should be 153, I believe, because I just did this, 9 times 17. But 18, alpha window, choice 8, 2 is 153. All right, there are 12 employees in the sub shop. How many ways can the manager choose 4 of them who have to work? Doesn't matter what order they're picked in. So it would be 12C4. All right, that's the end of the first part of the lesson.